Welcome to ERC Tipsnology. In this video, we will be learning how to create a parallel circuit using the Multisim Live or Multisim.com. Of course, open an account in Multisim.com and let's place 3 resistors on our screen. We do that by just clicking the resistor symbol on the left side of the screen. After that, let's click one more resistor, the second one, and put it over here. Just click the resistor symbol again for the third time, and as you can see here, we have the third resistor. Now you may use the grid lines to align the position of the 3 resistors. As you can see, R1, R2, and R3 are in line in a horizontal position. And then let's click the voltage source and put it on the left side. Now let's rotate the resistors one by one by simply clicking on the clockwise direction, and let's rename the voltage source from V1 to Vs. After that, let's see the value of the voltage source. It's equal to 5 volts right now, and I'll be changing it to another value, for example 25 volts. And then afterwards we can change the values of the resistors. Starting from R1, I'll have it as 500 ohms, and then for R2 I'll click the 1 kilo ohm and make it 100 ohms, and we will just leave R3 as 1 kilo ohms. Now the next step is to connect them together. So we will be clicking on the positive side of the battery and make a line or a line of wire up to R3, and then we will remove the displayed net labels from for number 1, and then we click on R2 and connect it to our wires or our wire at the top, and then click the negative side of the battery and drag it downward until it reaches R3, and after that we remove again the net label or the wire label, and then click on R2, connecting it to the bottom part of the circuit, and also with R1, and there you go, you have your parallel circuit. Now let's put a ground on the lower portion of our screen, approximately here in the middle part, to make it run, and then we will now put the voltmeters. So we start by measuring the voltage of Vs, and then we drag another voltmeter and measure the voltage of R1. We will call it V1 later on, and then also for R2 we will put a voltmeter there, and the last one is R3. This is to prove that the voltages in a parallel circuit will be equal to the same value. Now let's change the names of our voltages. From V1 we will make it Vs, and then for probe number 2 I'll make it V1. For probe number 3 I will make it V2, and lastly the PR4 I will be making it V3. And there you go, we have changed the names of the voltages. Now let's try it. Let's run the circuit, and as you can see, the 25 volts on Vs is equal to V1 equals V2 and equals V3. Simply put, this proves the fact that in parallel circuit all voltages are equal. Now let's click on the ammeter and let's measure the current coming from Vs, which we will call as I total, and also the current through R1 and through R2 and through R3, and we will be calling it later on as I1, I2, and I3. Okay, so simply drag and drop, and let's change the name of PR1 into IT, for example, and the PR2 would be I1. Let's change PR2. Okay, let's make it I1. There you go, and then let's change PR3 or probe 3 into I2 to represent the current through R2, and PR4 let's make it I3. And there you go. Now let's try it. Let's see the currents. As you can see here, we run the circuit and we have 325 milliamperes for IT. and the sum of the 50, 250, and 1 to 50 and 250 and 1 and 25 would be 325. Now let's try to see what will be the current here near the intersection of R1 and the VS. So if you put a probe there, it's also 325 milliamperes, thereby proving the fact that the current going to the node of R1 will be equal to I total. Now let's also put some ammeter here between the R1 and R2. What would be the current over there? So you will see that it's equal to 275 milliamperes. When added to 50 milliamperes, that would be 325. And let's try also to see what's the current after R2 or between R2 and R3. Let's see that. Of course, that would be equal to 25 milliamperes, which is also flowing on R3. So this proves that the current on R3 is the same with the current coming out from the intersection of R2 and R3. And let's be curious about the other currents. Let's see what's the current at the bottom. Although we know it would be 25 milliamperes, we will just look at it with this multisim circuit to prove that it's really 25. See, it's really 25 milliamperes. Let's also put another one here near the ground at the bottom. Let's stop running the circuit and let's put another ammeter at the bottom near the ground, and that would be equal to 275, I think. Oh, see, it's also 275 milliamperes, same as the top current. And let's put another one here near the voltage source in the negative side of the battery. It would be equal to 325 milliamperes going or coming back to the negative side of the battery. So the current after the positive and before the negative will be equal to 325. Also the one going to the node for R1. So there you go. That's how to create a parallel circuit using Multisim. Isn't it very easy? So you can try it by logging into your account in multisim.com, but you have to create your account first so that you can try this circuit, and this would be useful in determining the values of currents and voltages. So thank you so much for watching this video, and I hope you learned something today. Have a nice day and please subscribe.